Good morning, all. Woo! Welcome to Reinforce.
Welcome to Reinforce. My name is David Kilman. I am a principal engineer on the AWS CloudFormation team. And joining me today is Joe Aliotto.
Yep, and I am a specialist solutions architect that focuses on cloud ops here at AWS.
Yeah, and today we are extremely excited to talk to you about CloudFormation Hooks and how to do proactive controls in your IAC. I am, like I said earlier, a principal engineer on the AWS CloudFormation team, but even I recognize that CloudFormation is not the end-all, be-all of IAC. So Joe will actually be showing us how we can use CloudFormation Hooks with other IAC tools like Terraform today as well.
Mm-hmm. All right, so let's just kind of dive into it. All right, so this may look familiar to some of you. This is, generally what provisioning with IAC looks like. Talking about CloudFormation right now. You start off with your code. You commit it to your repo, run some CI/CD pipelines, do the test, the deployment, make sure that everything's functioning as well, and you get resources, right? A lot of us are really familiar with those patterns, but how do we implement some guardrails around that, right? So kind of shifting left some of the responsibility, or I shouldn't say the responsibility, but shifting left some of the guardrails to ensure that what you're deploying is what you should be deploying, whether that's related to security, whether that's related to cost, and making sure that when you deploy something, you don't get a call after hours. Let's see if it goes. There goes the little card, keeping you in the guardrails, right? And so that you're not getting those calls after hours or saying, hey, you deployed something that isn't within the requirements for this specific environment. So a lot of the IAC development has been changing a lot lately. We've all heard of generative AI. We're not going to talk a lot about that today in this talk, but developers are commonly experimenting with that, starting to develop using that and maybe vibing a little bit here and there. So we need to make sure we have guardrails that can be more to the left, that as you're trying to build and deploy that IAC, you're notified before those resources are created or those resources are stopped from being created so that you're maintaining the specific requirements that your organization has. So this is where we bring in CloudFormation Hooks. Right? And we're shifting those controls more left, right? So you have your template on the left. That's just a CloudFormation template. That generally gets uploaded to S3. CloudFormation can have hooks configured, which can have different controls related to resources and the different properties. Like for Lambdas, you can manage runtimes. You can also manage specific security frameworks, like SIS2, for example. Like you could deploy a hook that is managing your resources at that level, so it's a lot easier to maintain those standards. And so as you try to deploy that, you can choose various levels, which we'll show you in a bit, to where it can be assessed and either warn or fail at deployment. And in this example, we're showing that you tried to deploy this resource, it failed, and so you're notified before that ever got deployed, so you don't have to come back and build it again or destroy it and then build it. You can build it right the first time. And this is where CloudFormation Hooks comes into the control narrative. So it's right below preventative controls, right, under proactive controls. Proactive controls are specifically around resource creation. And so what we're doing is we're providing the guardrails around creating those resources so only the proper resources for your organization can be deployed, or you're notified that, hey, you need to maintain these standards. It's kind of up to you. And what I'm going to do is I'm going to go ahead and pass it over to David, who's going to go through some use cases, and I'll let you take it away.
Cool. Okay, so I want to do a quick survey of the room. Who here considers themselves platformy security people? You're in charge of writing rules. Okay, we got a few. Oh, we got a lot of you in the audience. Nice, nice. Who are my fellow developers? The people for whom those rules evaluate against? All right, we got a couple of y'all in here too. All right. Have any of you developers been paid for creating something 15 minutes after the fact? This happens, I feel all the time for me. I remember specifically when Lambda launched its functioned endpoint feature a few years ago. I was so excited. I went into my little AWS console. You'll see it soon. I turned it on, and I was like, this is great. And then I went home, and I was riding my bike home in Seattle, and my phone just starts going off like crazy, and it turns out function endpoints were not something that we were supposed to be provisioning in our own accounts. And so I just pulled over on the side of the road and pulled out my laptop and had to delete my Lambda function. After that day, we all got together and were like, we have to find a better way. And so that's what Hooks does. Hooks lets you like prevent bad things from happening. So there's lots of different types of things Hooks can help you prevent from happening. In this case, it's sort of a security-related thing. This is similar to the story that I just told you. So like, I'm an organization. I want to make sure, I want to stop seeing COEs where people don't have bucket encryption enabled, right? So I just create a simple guard rule or a rule that says no more buckets can be provisioned through CloudFormation unless they have bucket bucket encryption enabled. So that's one really like great example of how hooks can be used. Another example is sort of targeted toward people like me who are really prone to creating typos. So this is a real life example of an auto-scaling group where I accidentally set the max size of my auto-scaling group from 100 to 10. If this change got deployed into production, my auto-scaling group would have lost 10x its capacity, and all because of a silly typo. So this is a real rule from my team where we have this check that makes sure that resources with provisionable IOPS, like auto-scaling groups or DynamoDB tables or EBS volumes, don't have a dramatic reduction in capacity. This hook is really interesting because it can fail. It can say, hey, like this failed the rule, but it also doesn't have to block provisioning. It can provide me, as a developer, a warning saying, hey, are you sure you want to remove all of your host capacity in production? So this is a super useful example of how hooks can help not just stop bad things from happening, but stop accidents from happening. And finally, another example is following sort of organizational best practices. So in this example, there's a certain type of EC2 instance that my organization wants me to use because we have a savings plan for it. So when I try to provision something, if I just go to Stack Overflow or like find like how do I create an EC2 instance, and I just use an M3 XLRs like everyone in the entire planet does for all of time, my organization can say, hey, actually, David, before you provision this like $10,000 an hour EC2 instance, maybe try one of these other instances first. So these are super cool. We are working on hooks a lot in the past year. It was sort of our focus in CloudFormation on the security side. We've launched a lot of new features, including different times when hooks can run. So running them, the core of hooks is we stop bad things from happening, but hooks is built by developers, so we also are trying to improve the developer experience by surfacing those errors super early on in the development practice. So offering different places where those hooks can run earlier in the development process, but also expanding beyond just CloudFormation. We totally understand that CloudFormation is amazing and generally considered a perfect piece of software, but it's not the only thing people use, right? So expanding that to other IAC tools like Terraform. Cool. So talking is cool, but coding is better. That's what they pay us for. So I'm going to press the HDMI button and take you to my AWS console. Okay. Cool. All right. So let's create a hook, everybody. So by the end of this like little code talk, I'm going to show you us creating a hook. I'm going to show you how it catches like terrible, awful things and how to debug using that hook. So let's just get into it. So I'm gonna go to CloudFormation. This is my like play account at work. So you can see I have some fun stacks here.
Could you zoom a little bit?
Yeah. And you can see on the left there's this section called Hooks for hooks with a hooks overview. And this hooks overview page is super useful. It provides a much less colorful version of what I just described to you. Hooks being a tool that can stop bad things from happening. It can help enforce organizational best practices, cost saving stuff. Stop your developers from accidentally fat-fingering their entire auto-scaling groups. So it's super useful, but now we're actually just going to go ahead and go create a hook. So there's two ways you can create a hook. You can create a hook with a Lambda. So basically, you give us a Lambda function, and you return yes, no, and we provide you all the information we have about the resource being created or updated. That's super useful, but I'm gonna use Guard, and I'm gonna show you why in a second. So Guard is AWS's declarative policy as code language. It's a pretty concise DSL for describing what can and cannot happen based on certain rules. But my favorite thing about Guard is that I don't have to ever write Guard because, in Guard, we have this open source registry on GitHub called the AWS Guard Rules Registry, which has a ton of rules already defined for a bunch of different resources. So let's find a resource that I feel is often a place of some concern. So these are all a bunch of rules targeting IAM resources. So one of my favorite policies. So every year we get a bunch of new interns at Amazon who are really excited to go build stuff, and in their eagerness, they are trying to find the quickest path to success. The quickest path to success for our interns often includes creating an IAM role with an administrator access policy. So this Guard rule, for example, makes sure that there is no star policy allowed in IAM for creating roles. And there's a bunch of other exciting policies too. So I actually went ahead and cloned this repository earlier, and I chose some of my favorite rules. So I have a DynamoDB, a couple DynamoDB rules, an IAM rule, some for Lambda, some for S3. And what I did is I zipped them up. Guard rules. And I uploaded them to S3. So I just uploaded that same set of Guard rules from that repository. I didn't look at them. I just looked at the title. I was very lazy, and I zipped them up and I put them into S3. So now if I go back to my hook, my Guard hook, I can actually just say, I can put that zip file from S3 into this configuration. And Guard, it has a very verbose logging. It will tell you so much about what went wrong and why a rule failed or succeeded. And so I'm going to tell Guard to write the results of its evaluations to the same S3 bucket, just for convenience. Cool. And really amazing Guard hook. I'm going to create this hook. I'm going to call it the really amazing Guard hook. And now in hooks, this is sort of getting back to what Joe was talking about earlier. There's lots of different places in which your hooks can run. So today, right now, we're going to target resources. So when your CloudFormation stack is creating or updating a resource, the very first thing it does before it does anything with the underlying service is it's going to call this hook. And it's going to pass the content of this hook, of that resource to the hook. For evaluation. We're going to talk about these other ones soon too. Don't worry, they're part of the act. And we're going to tell this hook to only run when resources are created or updated. I'm going to tell this hook that if it detects a problem or if a rule fails, rather than warning me and letting provisioning continue, I'm going to have it hard fail. This hard fail is going to stop the thing from happening at all. And then I'm going to call it my very good Guard hook role. I'm going to create a role, and that role just allows that Guard hook to write and read from S3. You can tell hooks to target specific types of resources, but because I have a bunch of different rules for different resources, I'm just going to have it evaluate every resource that CloudFormation is provisioning. And I'm going to activate this hook. Oh, sorry. Whoops. Yay! Let's see. Did I do it? Cool. So I have my extremely good hook here, and we're going to play around with it. But before we do, I wanted to show you something that I worked very hard on. So earlier this week, I asked a GenAI agent who will not be named to generate a CloudFormation template. Joe said there's going to be no GenAI in this talk. He's wrong. I asked GenAI to generate a super simple template, a CloudFormation template with an S3 bucket, a Lambda function, and a DynamoDB table. And that Lambda function has permissions to talk to that DynamoDB table and S3 bucket. So this is a really simple template. We'll just go over it real quick. It has a Lambda execution role, a Lambda function, an S3 bucket, a DynamoDB table. And look, the DynamoDB table even has point-in-time recovery turned on. So it's a decent template. It will work. If I threw this into CloudFormation 10 minutes ago, it would generate all these things. But we're going to see how this holds up against the hook that we also just created. So I'm going to create a stack. I'm going to upload this template. So from the web. Don't look at the fixed ones. This will probably work. I'm going to create a stack. I'm going to impress all the buttons. And I'm going to create the stack. Cool. So, now you can see CloudFormation, I'm going to zoom out a little bit just to show us the map. So the very first thing CloudFormation started to do was it was noodling on which resources it was going to create. So it's going to create a Lambda execution role, a DynamoDB table, an S3 bucket. But the first thing it did when it tried to create, for example, this S3 bucket, I'm going to zoom over here, is it started invoking our really amazing guard hook. So you can see it's like, okay, like, this resource matched the hook filtering, so I'm going to run the hook first. And then when it tried to create all these resources, it failed because the hook itself failed. So in this case, the guard hook, failed, and you can click it. And it has this little message saying, like, this hook failed, the template failed validation, the following rules failed, S3 bucket default lock enabled failed. Okay, that's a lot of words. But we can tell that this S3 bucket that we created did not pass that hook. And so let's dive into why that happened. So I'm going to go back to S3, where the guard hook wrote its validation report. I'm just going to take a look. You can see that a lot of different resources failed. My DynamoDB table, my Lambda execution role, my S3 bucket, they all failed validation. I'm going to check the logs to see what happened. Boop, boop. Okay, so this is, when you run guard, you get this like really nice JSON output. When we write the logs to S3 from the guard hook, you get a really, really detailed explanation of what went wrong. So in this case, the rule S3 bucket default lock enabled failed, and it could not find the object lock enabled property of my S3 bucket. And it's saying that in order to fix it, I have to set object lock enabled to true. Okay, I don't know what object lock enabled is in S3, but I'm going to go look at my template. And I can see that I have my S3 bucket. There are literally no properties. So what I'm going to do is I'm going to add a property. And I don't know what this property is. It's telling me to set it to true. So object lock enabled must be set to true. Okay, cool. So I set this to true. So let's see what happens if I try to create that CloudFormation stack again. Okay. So I'm going to upload my, this will really work. I'm going to create my stack. Boop, boop, boop. Okay. Okay, so you can see that CloudFormation tried to do a bunch of stuff again. This time it still failed. Why? Why did it still fail? So let's go take a look. Okay, so this time it failed, but failed for a totally different reason, right? S3 bucket public read prohibited is not set. This makes sense, right? If I have a bucket, I probably don't want it to be publicly accessible from the internet, and I want to be able to say, like, this bucket is prohibited from being read. But this developer experience kind of sucks a little bit, right? Like, having to go through CloudFormation and try to upload a stack and then wait for it to provision resources one by one and wait for the results of this hook to happen. It's really slow, right? It's just so slow, and especially once you start throwing in resources that take longer to stabilize, right? Like your ECS services, your CloudFront distributions, things like that. You don't want to have to be using like upload, like your development cycle should not include updating a CloudFormation stack and waiting for it to finish. So luckily, hooks can help with that too. So I'm going to go back to our cool guard hook. I'm sorry, our really amazing guard hook. And I'm going to edit the behavior. So right now, this hook is stopping bad things from happening, right? I couldn't provision an S3 bucket that was not, didn't have object lock enabled. I couldn't provision a bucket without read access blocked. But I actually want this hook to run earlier. So I'm going to tell this hook to run whenever I create a change set. And now I'm going to show you what that looks like. So I'm going to try another stack. Oops. I'm going to choose the same template that I was just looking at. Hopefully this works. I'm going to tell it we're chill. And this time, instead of pressing submit and creating the stack and going through that whole process of CloudFormation actually trying to provision, I'm going to create this thing called a change set. Quick show of hands, has anyone here used change sets before? Okay, cool, lots of folks. Basically, a change set is a plan that CloudFormation generates before it starts to do anything. It's going to tell you, here are the resources I'm going to run, I'm going to try to create, here are the resources I'm going to try to update, and here are the properties I'm going to set. But you can see when you have a hook that blocks, that targets a change set, before that change set becomes executable, your hook can actually run and evaluate your set of proposed changes as well. So I took the same exact hook I had, the same exact code, the same exact rules that were targeting my resources, and had them run on the plan that the change set was generating. And so now you can see I get all of the error messages up front. Like it evaluates every resource that's going to be created, updated, or deleted. And you can see it's like, oh, okay, great. My DynamoDB table must have encryption turned on. I have a IAM role with administrator access, just like our interns. And my S3 bucket still doesn't have read prohibited turned on. So this is a much faster development loop for me as a developer because I can just in one place see all the rules that were evaluated and whether they passed or failed and get all the details in one file. So I just want to show you real quick, this is sort of where we were. So I had this Lambda function, it's really cute, this seems fine. I have my S3 bucket, I had object lock enabled turned on. And from this, I'm going to use a little bit of movie magic to actually fix this for us. But now, because of those hooks telling me, hey, David, you're trying to create crazy things, I was able to go through and, in response to all those rules failing, update this template. So in response to the IAM role having administrator access, I put in a least privilege policy. So I gave it a basic role that policy that allows that Lambda function to run, and gave it specific access to the S3 bucket and the DynamoDB table being used in this template. My Lambda function was totally fine and perfect, so I have no critiques for that at all. It's a work of art. My S3 bucket, we saw I added object lock enabled earlier, but now I also added this public access block configuration. And in my DynamoDB table, I had point in time recovery turned on, but I also turned on server-side encryption. Cool. So with this new and improved template, I'm going to go and try one more time to create my template. I have my movie magic version. I love policy as code. Okay. Next, I'm going to create a change set. And now you can see that our hook is running, and this time the hook passed validation. So I can go and actually look at all the changes, and here are the changes. I'm going to add all these resources. They've been pre-vetted, they're compliant. I'm going to execute this change set. And now, even though the hooks ran at change set time, they're still going to run when creating this stack as well when the resources themselves are provisioned. So that's a super quick rundown of going from 0 to pretty decent policy enforcement in my account using CloudFormation and CloudFormation Hooks. I'm going to hand it over to my buddy over here to show you how the same hooks and policy and all that stuff works with Terraform.
Yeah.
Cool. Okay.
Awesome. Go ahead and just I'm going to switch it over.
Nice.
We're back. All right. So as I get set up here, has anybody written a guard policy? Anyone? One, two, couple? Actually, I'm surprised. That's great. Does anyone use Terraform today with either their platforms or anything else? Yeah, awesome. Great. Let me get in here. Just give me a second, make sure we're good before I switch over. I'm going to refresh this. All right, awesome. Cool. Let me get connected, and we'll be good to go. All right. Demo gods. Yes, we're in. Awesome. All right, so what I'm going to do is I'm going to cover the creation of a guard policy. Something you may have noticed if you're looking very closely at David's CloudFormation template, he was deploying a Lambda function that was on Node.js 16. That's a deprecated runtime. You probably don't want to be deploying deprecated or soon to be deprecated runtimes that you're going to have to update soon. You probably want to control that and have something a little bit more recent when you deploy that. So first off, I just want to show you, I'm not going to create it again. Oh, whoops. 1 second. North Virginia. All right. So I already created it. We're going to look at what this guard policy looks like, but I just want to show you something a little bit different here. So when I go to this, what I'm using is the Cloud Control API. We looked at this previously, right? We looked at the resources and the change sets. But with Terraform, we offer not only the provider that's the AWS provider, but there's also the AWS Cloud Control provider, which is the AWS CC provider, which will enable you to be able to utilize hooks. We're doing the same thing looking for the actions of create or update, and we're going to fail on those. And so before I jump into the policy, I'm going to deploy it now to give it time to deploy the resources and fail, and then we'll look at the policy. So let me go ahead and do that. Hopefully my credentials are still saved. We'll see. All right, we'll give it a second. Just want to make sure we see. All right, it's doing things. All right, great. Okay, so I'm going to just switch over here so we don't have the scrolling, and we're going to just kind of block out one thing at a time. So what I have here is that guard policy that I created. Some of this may look a little familiar. Like what we're doing to start off is we're creating a variable using let called Lambda functions. And what that is we're looking at the resources in a cloud, in the cloud control provider, right? If you think of the CloudFormation template, there's always that resources section, and then you define what those are. This is basically using that same methodology, but where do you find this, right? How do you know what resources you're defining? And so let's take a quick look at that. We have the AWS resource and property types reference. And so I know I want to do a Lambda function, so I'm going to go ahead and go to Lambda. From within here, I found the resource type, right? AWS Lambda function. What you'll notice, and I'm going to click through here for the next part, is that is exactly what I have defined here is the resources, or all resources, that match the type, that AWS Lambda function. So that's what I'm looking at first. Now next, what I want to look at, and let's make space. I'm going to try to focus it, because that way we're just looking at what we want to here, is what we have is now we're defining the guard policy rule, right? We have the rule. And this rule is called the Lambda already deprecated runtimes. And so we're looking at when all of those Lambda functions, that variable we defined before, any of the resources that are Lambda functions, are not empty. For each of those functions, we're matching the properties when the runtime exists, right? And so how do we get that? Where does that even come from? So if we come back to the resource provider, what we have, if you notice, remember the type I mentioned before, type Lambda function, that's where we define that. The properties is from the property for that resource, and then specifically the runtime version, right? So that's how we're defining this specific area of the code. So next, what we're looking at is, when the runtime does exist, and the runtime is not in these specific versions, that the rule will pass, right? So these versions are deprecated runtimes. Where did I get that? right? How did I know what they are? Back to the documentation, if you look at the allowed values, we can see all of the allowed values for that property. So we can start to define that to say, if it isn't matching these rules, right, we are gonna pass this rule. But if we do match it, we're gonna output a message, like we saw previously, that says Lambda function is using a deprecated runtime, right? And so, and the way you just open and close it is kind of those brackets, right? Additionally, these are already deprecated runtimes. I want to know when something's soon to be deprecated. It's the exact same thing, but I'm using specifically Node.js 18 and this provided runtime, right? And then I have a different message that's saying Lambda function is using a runtime that is targeted for deprecation. So it's not deprecated yet, but it is soon to be, right? And so using that rule and using the resources guide, we can go through the various properties we want to define very granularly and understand exactly what we want to allow or not allow and be able to create those rules. All right, so let's take a look at what we have. And I'm going to zoom this up. Actually, I'll just go up all the way. Oh, we have an error. Can anyone tell me what that actually is telling us? Anyone? I mean, because I can't tell either. Okay, so we're actually working on improving this integration with the AWS Cloud Control API so that you'll actually get the message. But key thing that I'm going to show you is we can get what the information is that's saying like what that failure is based on this ID. So what we have is, I'm going to go back over to this little README I kept so I wouldn't typo, is you can look up the hook results for the cloud control provider with the ID it provided for the failure. So I'm going to copy that. All right, we'll come back over here. I can, if it wants to paste for me, we'll paste. There we go. I'm going to grab the ID, which is right here. All right. And then we're going to paste that. And when I run that, you can now view, and let me do more, and I'm going to shrink it a little bit so we can read it. You now get more of an idea of what happened. So you can see that it was during the pre-provision process, it failed it, right? It was the lamb time runtime checker guard policy, right? It shows that it failed. It gives you that reason that the Lambda already deprecated runtime, failed validation. If I want to know more, if I'm a developer, I don't want to like have to go into the console and change. I want to do it from my terminal, right? So what you can do, and this is a little cool trick if you've never seen it before, is you can go AWS S3 where it saved it. You can copy the location, and if you put this little dash, it writes it to standard out. So it's going to write that file to your terminal so that you can read it. And now if you remember what David showed previously from the JSON, you can just view in your terminal. I think the one thing, like I mentioned before, is we are looking to be able to have the errors output a little bit more cleanly so you know what's going on when you initially get that output. But what I'm going to do now is I'm going to go ahead and fix that. So let's fix it. Let's look at the TF again. So this is my main Terraform, very simple. It was the exact same thing that David had deployed. But if you notice, I'm using that AWS Cloud Control provider. I'm going to go down to the Lambda function. We see we're Node.js 16. Let's change that. I'm going to just change it to 22. We'll save it, and then I'm going to clear screen, and then we'll just maximize this. We're going to go ahead and apply again. We'll see what happens. And so this time you'll see, when we get here, it's only deploying that new resource that it couldn't deploy before. It is Node.js 22. And then it's just going to go ahead and create, and it should be successful. Fingers crossed. Demo gods, please. And so we'll give that about a second to go. But I think as that's going, and we'll come back to this in a second, the resource guide really is the most simple way to find exactly what resources you want to define if you need to do something a little more granular. The repository that David showed before, as I hinted at previously, was that not only does it have specific resource types, but there are also different security frameworks that are already available that you can apply using those pre-built guard policies. And so instead of just having to deploy individual like IAM guard policies or like going through the specific ones, the framework's already built and kind of ready to deploy, and you can test and see where that meets for your business requirements. And then you can modify those effectively by using these specific resources, which we'll go back up one more, in the resource and property types reference, right? If you need more granular controls around one specific access, or if you need to loosen it up a little bit for your environments, you can do that as well. So let's go back over here. All right, the apply completed. We can see our outputs. We have that DynamoDB table. We have that Lambda execution arm. We have the Lambda function and the S3 bucket. So not only have we shown you could do it with CloudFormation, specifically in the console or programmatically, you could do that, but also with Terraform and being able to use the cloud control provider to manage the same policy as code for your environments. But we definitely acknowledge that the error is not very clear, and that's something we are working on, and we want to make it just as clear as it is in the console today, but from the terminal tomorrow.
Yeah. Does anyone here use organizations for bootstrapping their accounts? Cool. Would folks be interested in seeing how to get a hook distributed to your organization using stack sets?
Yeah.
That's what we're talking about. All right.
Yeah, let's go. We're going to switch back.
Yeah, cool.
Let's go. I'm going to switch this over. All righty.
While I use a computer, does anyone have any questions right now? Cool. Yeah, sweet. So I'm going to show you one of the nice things about, let's go here. One of the nice things about hooks as like a thing in CloudFormation is they are also CloudFormation resources. So we can actually provision a hook in CloudFormation the same way we would any other thing that we're going to create. So in this example, I'm going to create a Lambda hook. And as part of this Lambda hook, I'll just show you. Let's create a Lambda hook. So we're going to create a stack. I'm going to upload a template. See if I can. So Lambda hook. So now, when I create I told you earlier there's two ways to create a hook. One's using Guard, and that uses our policy as code language. And the other one is using Lambda. And so if I go and create a Lambda function right now, let's see, this one seems good. Image scanning, cool. So I have this really cool hook that I wrote earlier. We can look at it in a second. But if I paste that hook function arn in, we can call it org lambda hook. Let's see. CloudFormation will go ahead and create that Lambda hook for me the same way that I was doing it in the console, right? So just a normal, regular CloudFormation resource. You can provision it in a stack. But what that means is that if you use stack sets, so if I create a stack set and I upload this hook, my rad stack set, and I give it the same, sorry, boop, copy, cross, org, lambda hook. Yeah, so now, since this is just a normal CloudFormation template, and I'm using stack sets, I can choose to deploy it to my entire organization or to my organization units, right? And so I don't have any an organization set up in this account, but you can see that just using stack sets and the fact that hooks are themselves regular CloudFormation resources, they can be distributed across org to all of your organization. The other thing that means is that when you create a function, like a Lambda function, for example, that you want to be used cross-org, you do have to have a cross-org policy set on it so that people, a resource policy on your Lambda function that says anyone in this org can execute this Lambda function. You can add an additional condition key to your IAM policy or your resource policy of your Lambda function that says, and like anyone in my org can execute this Lambda function, and it's coming from hooks. I'll populate that IAM condition key. That's how you can have one hook get blasted to your entire OU and start enforcing things. You can use tools like SCPs to stop people from being able to disable hooks in their account. And sometimes it's nice to give people the option to disable certain hooks in case they need to do things like overrides, like my friend was saying, for non-critical things. But the same ability to blast your hook across your entire organization works with the guard hook as well. Similar thing, you bootstrap it with an S3 file that has your guard zip file in it, and you can put a object policy on that allows anyone in your organization to read from that S3 file. Yeah, so that's how you use stack sets to blast hooks to your organizations. We've been using this internally with some fun kind of in CloudFormation land to make sure that people aren't over provisioning their DynamoDB tables. We had a bad habit of when folks join. DynamoDB used to have this pattern where in order to like have it sharded across, like to pre-warm your DynamoDB table, you would over provision it so it would create lots of different shards, and then they would lower that provision throughput or switch to on-demand throughput. But sometimes people would forget to do that, and they'd end up just having these DynamoDB tables with 10,000 read and write IOPS provision just hanging around in their beta accounts. So we've been able to like blast hooks to those accounts to make sure that they're not doing that anymore. DynamoDB fixed, like they have a feature so you can pre-warm tables now. So that's a real life example of how we've been able to shift like across the CloudFormation organization, like this bad habit of accidentally leaving DynamoDB tables over provisioned. Cool. Do folks have any other questions? Does that make sense on how to distribute it across organizations? We just use stack sets. It's a pretty simple thing. I will show you one fun thing, because speaking of managed runtimes being kind of bad, so I want to show you my Lambda function that I created real quick. So this, I'm not going to go over the code of this too much. I will show you, we have this documentation for creating Lambda hooks that's pretty good. Basically, I mentioned before that when you create a Lambda function, we give you basically this JSON blob that you are free to use to evaluate whether something is, a resource is compliant or not. In my function, I'm targeting any resource that has something that looks like a container URI. And if it is a container URI that's registered in ECR, I can actually call ECR to see if the image that's being deployed has any critical findings. So does anyone here use containers on the reg? Okay, sweet. One of my favorite features in ECR that ECR has launched, I'll show you real quick. It's super great. Is like when you publish an image to ECR, it can scan it for vulnerabilities. And so you can see I have this this image called Mega Good API. It's a really amazing service that I'm writing in my spare time to make my first billion. But when I push it to ECR, it automatically scans it and it's like, oh, there's a bunch of critical issues here. That's really cool, but basically up until now, no one cared. Nothing cared, right? Like CloudFormation doesn't care. It's like, yeah, sure, if you want to provision like an ECS service with an image with a bunch of critical vulnerabilities, that's totally chill. And eventually we get back into that situation that I was talking about earlier when I was on my bike ride home and I deploy this and everything works, and then like 20 minutes later I get paged because, oh no, an image with vulnerabilities has been deployed. So this image scanning function that I wrote, all it does is it like extracts the image URI from my template. It looks to see if it looks like an ECR image. And if it's an ECR image, it calls describe image scan findings. And if it finds any critical findings, it fails the hook. And so like I could take this now and have distribute that across my entire organization. Like while I was sitting here talking to you, we could have my entire organization no longer able to deploy images to ECR with critical security vulnerabilities. Cool. So that's kind of all the fun stuff that we had prepared.
So thank you all.
Yay, thank you all.
Take care.